Hello and welcome to this video. We are going to look at vapor pressure lowering, or simply put, lowering of vapor pressure. In our previous video we had a look at an introduction to colligative properties, but today we want to see the main colligative property that is behind other three colligative properties. So our emphasis is going to be on vapor pressure. So once you have your solute, we shall stick to our water. Once you have your water molecules in a given container, these water molecules tend to escape and form what we shall call their vapor counterpart. They will tend to escape and form some vapor. And the pressure due to this vapor is what we shall call the vapor pressure of this water. And it's because of the water molecules that have evaporated. So the evaporation of water tends to increase the vapor pressure. However, when we add a solute into our water, this solute can be ionic or it can be covalent. So once we add some solute into our water, something will happen. We shall start seeing that we shall no longer have the same vapor, or we shall have a reduced escaping tendency of these water molecules. So how is that possible? Remember, when a solute dissolves in water, we shall say that solute has become hydrated. And we can have two types of solutes. It could be ionic, for example our salt, say sodium chloride. Once it's dissolved in water, its ions, the sodium ions, will tend to interact with the water molecules. Remember, water molecules are basically kind of polar because the oxygen atoms are highly electronegative, so we shall have some water molecules present. And these water molecules will tend to interact with these ions. So we shall have some force of attraction between the ions. So this is attraction and the water molecules. So because of that kind of attraction, we shall have a reduced escaping tendency of these water molecules because they are being pulled back by the ions that have been dissolved in this water. However, for molecules that are covalent, for example sugar, we shall see that sugar can actually still form some hydrogen bond. We can have some hydrogen bond between the sugar molecules. Remember, sugar is not ionic, and then our water. So still water can kind of interact with the sugar particles through hydrogen bonding, and this hydrogen bonding somehow inhibits the escaping tendency of our water to form the vapor, thus increasing the vapor pressure. So because of the reduction in this vapor that is escaping, we shall say we have obtained a lower vapor pressure because we have less water molecules escaping into the atmosphere. So because of that, we tend to have a reduction in vapor pressure. We can easily show that by using a basic mercury barometer. So we have our mercury here. If you look at this image, we have our mercury here in this column here, and then we have our water. If this is A and this is B, we have our water here in this tube, and then we have our solution here. It could be a sugar water solution or a salt water solution. But one thing you realize is that the space between the water and the top of this column is bigger as compared to this other one here. It's because the water vapor pressure, because as this water is present, it is escaping to create some vapor here. So this vapor here creates certain kind of pressure. So this pressure is too high that the mercury column tends to drop down. However, the vapor pressure due to the solution, when the solvent particles, say the water, evaporates or turns into vapor, it will form less vapor pressure if at all it is in solution form, that is to say if we have some solids present, and as such we shall have a lesser length of this empty column or the vapor column. So you realize that the pressure due to B is less than the pressure due to A. So we shall say that the pressure obviously in this one here is greater than the pressure in B, because we have less vapor pressures above the corresponding liquids. So presence of a solute in a solvent will always lower the vapor pressure, because we shall have a less tendency of the water molecules escaping or whatever solvent that we have. But this is true on one assumption, or on assumption that the solute is not volatile, because if the solute is volatile, that means it will also escape and contribute to the vapor pressure. So we shall have to assume that our solute is non-volatile, such that it's only the solvent stroke the water that is contributing to the vapor pressure. We shall look more at this topic of vapor pressure lowering as we proceed in our series. Thank you for watching. Be well.